Hello, Professor. It's Alexandre AMATE for the problems of Chapter 9 you assigned us. So from 9:10 to 9:14. So 9:10. Prepare spirit stem and leaf plots for the dead score for each of the floor newly developed object test, etc. So I did all the exercises on R. So here are with the stem function, we can obtain the stem and leaf plots. So here are the results. So for test one, we can see that the average score is more around 100 or 80, and those numbers are because those numbers have the highest frequencies compared to the others. For test two, here, the frequencies are the highest around 90 and 100. The average number should be around 98. And for the test three, it's more around 90 and 100. So the average should be there also. And for test four, it's around 180. Those are the more highest frequencies. So test one seems close to the test two with similar frequencies, whereas for test three, the employee seems to have an average high score. Test 1 is the most spread with 140 for the highest and 62 for the lowest, but the average test seems to be more around 100 each time with an high frequency for each test. So we obtain the scatter plot matrices, etc. So with the function pairs, we obtain the scatter plot matrix. So here's the matrix. So it seems to have a linear relationship between y, x3, and x4, meaning they must be most correlated here. You can see linear function. So here. Meanwhile, for x1 and x2, the result is much more cloudy, but we can distinguish a linear scheme behind the clouds with a progression like a linear curve. But the result is still cloudy, so we cannot save anything from it. Yes, there we can see like a bit of a linear, like it's following a linear function, but it's still cloudy. So there, it's still cloudy. We cannot make sure of that. So we can verify that with the correlation matrix in the function or. So here's the correlation matrix. As I have found just before, y is much more correlated to x4 and x3 with respectively coefficients of 0.895 and 0.869 here. Variables x1 and x2 seems to be also correlated to y with coefficient of around 0.5, but much less than x3 and x4. It's still good, but it's not that good. So I don't think there's our multicollinearity problems, seeing that the correlation between y, x1, and x2 is still sufficient, like I said, doesn't influence badly the linear model. So last question, fit the multiple regression function, etc. So let's construct the linear model with the LM function. So use the function linear LM, linear summary. Here we have the function. Finally, have the function minus 124 plus beta 0, beta 0, beta 1, beta 2, beta 4. So our linear model is good with I r squared and adjust r squared values, 96 and 95, so really high. So it's really an accurate model, so this model is viable. So 9.11, so the following of the exercise, so using only first order terms for the predictor variables in the pool of potential variables, find the four best subsets regression models according to R squared criterion. So to find that out, I created all the possible linear models and compared them to the R value. So yeah, basically I created all the linear model different one here x1, x2, x3, x1, x2, x1, x2, x3, x4 here, etc. So I just looked up all the R squared value. For example, here, this is the R squared value. So the best R squared value of that. So for values x1, x3, x4, 0.956, x1, x2, x3, x4, 0.955, x1, x3, 9269, and x1, x2, x3, 9247. So in this model, basically all the R squared for all these values are almost equals. There's really little difference between them. So question B, since there is relatively little difference in R squared for the four best subset models, what other criteria would you use to map the selection of the best model? So I think that so other criteria will be the residuals of each models, see if there are any outliers, etc. Or maybe conduct some tests like power of test, Bromfish test, etc. Test on the variance for each models and look what's the best model. So we should conduct more tests with those models to, to seek for the best model, find it. So next one, 9.13. So here's this liver problem. Prepare separate dot plots for each of the predictors variables and the node holes using the plots. So here are the dot plots. So cloudy as ever, but it's normal because every time if we plot it, R is gonna just do like one first value here, first value two, third value here. So basically those plots indicate us like the average number. So here we can see that all the numbers are almost gather between 20 and 40, so around 30, and maybe the line, draw a line, then here same, it's between 20 and 40, so maybe more into 40, so maybe the average is around like 40, 48 or 42 because they're a bigger liar here, 100. Same here, they gather more around 40, 45. So maybe we draw a line at 43 or something. So other plots are cloudy. You can really get something like just for so B, obtain a scatter plot matrix, also obtain a correlation matrix, etc. Are any multicollinearity evident? So with pairs in core in R, we obtained those matrix. So this one we can't really say something. So we're just going to look on this one. So as we see in the matrix, we have negative coefficient there, and more we can see strong correlation between x1 and x2 there. 0.65 is quite strong. So this one indicates multicollinearity. So feed the motor regression function containing the three predictable variables as first order terms. So I created a model. So x1 is to x3. So we can see there that the multiple R squared values are quite low. So this is the function, but with the R squared that low, the model doesn't seem to be reliable. With R squared pretty low. Maybe if you got rid of the multicollinearity x1 or x2, or maybe we change or we do polynomial linear regression, we can obtain much better. So 9.14, last one. Using first order or second order terms of each of the three predictable variables, sector on mean, the polynomial. So basically find R squared, the best R squared, basically R squared for second order terms. So basically like it's the same as the question before in 911. I just did like some model like this with x1, x2, x3, but with the squared value. So basically, we got model, for example, we had x1, x2, and there x1 squared, x2 squared. So here are the three best I found: x1, x2, x1 squared, x2 squared. So they're all around 75, 74. They are really close. So is there much difference in R squared for the three best subset models? So the difference really insignificant there. So we can maybe choose the best model while conducting different tests like power test, etc. Just like the same answer, just the same answer as for the 911. So if we can do more tests, we can maybe find which one is the best of these ones.